Alright, time for another DraftScience video presentation. What's the point? It's just there's no intelligent life on planet Earth. Really isn't much point in attempting this conversation with the world or any of that because world's made out of crap and fish, just fish. It's all humans really are. They're still just fish. They really haven't figured out what to do with this brain thing. They just, dupes. Just follow the leader somewhere. Just silly. Just ew. Anyway, but I mean, I can only take care of my end. So in a sense, I have to just do this karma thing and just, I have to just worry about my job. So I'll do my job and attempt to reasonably interact with these word things, and that's all I can do. But it's just very little hope that any of you, have ears to hear with, or eyes to see with, or a brain to think with. No, you're just not up to this game. But anyway, I really do mean most of you. Anyway, so comments are just a waste of time. And as stated, even the people who can't phrase their comment in kind of civil language, you can email your proofs and your evidence. You can email me the link to the great video that proves me wrong and the great experiment that proves me wrong and all that crap. But nobody's doing that. So it's just clearly they can't form the argument in anything but rubbish. So anyway, some guy, who knows who he is, what he's up to, what's the point of it? Cayenne, I don't know what that means. Who are you? Oh, you're going to ask me who I am. So you have an unaccountable account. Okay, you can't even be bothered to create an icon for your account, and you're going to ask me who I am. Yeah, okay. That matters, right? So, no, who am I? Supreme Emperor of Basementopia. The grand owner of the blackboard. I own the blackboard. Yes, that's who I am. Among other things, no doubt. I have probably other great qualifications. Shoes. I own some shoes. The man who owns shoes. How's that? It's just like the last thing that occurs to me to ever type on a video is, who are you? It just doesn't even occur to me. Anyway, where did you study physics? So again, so I have to answer all these questions as if they're somehow relevant, and as if they're not somehow already in the videos, in a sense. What are your degrees? So these are the things that are important to you. It's not the message, it's the messenger. Because you're not really interested in wasting your time actually thinking about what somebody's saying. You're just saying, well, if they have enough integrity, okay, by some standard, whatever that is, they went to college, like George W. Bush, they're really smart then. Oh, wait a minute, that might not work either. But it's the same old crap. So, there's just so little hope here of interacting in any kind of rational way. I mean, I'm sitting here making the arguments, drawing the arguments, and they still don't get it, that it's about the arguments. Yeah, amazing. So, in like 70% of my videos, I'm actually playing somebody else's video, pointing out the errors. Let's ignore that too. Alright, but anyway. But there's just nothing here. There's just no point. Like I said, there's just no point. But there's no point in not doing anything, so I have to do something. It's a little bit of, whoa. It's a little, sorry. Technology. What I am not is the supreme owner of a bunch of great technology. So anyway, so we'll just go over some of the highlights here. So you have two theories in physics, two substantially. The big subject is gravity and relativity, time warping kind of nonsense. And then you have this other thing called quantum mechanics where, everything's doesn't know where it is, and the universe is random, and it's confused and weird. It's weird. So you have this weird theory and this just overtly silly theory. But anyway, so relativity, the big evidence, well, the point where Einstein became credible wasn't so much like, he did do the parallelium thing of Mercury. He did provide some mathematics for that, but everybody was pretty unimpressed because the mathematics are so convoluted that nobody even knows how they work. So he has this simple theory that there's this time dilation thing that's creating, these effects in the universe. And he's saying that, gravity is created by bent space-time thing, some bent curve. And yet, for a bent curve, he has to come up with this insanely convoluted mathematics to describe that. So that was sort of like, I guess some reasonable mind said, well, why does something so simple, why is it so complicated? Why do you need all this complex math to do something that's supposed to be just this simple curve? I mean, that's all it's supposed to be, is this simple. I mean, it's just this simple curve. Both the bent time and the bent space are supposed to be just a simple, really easy to state mathematical curve. So why do you need a whole convoluted pile of mathematics to describe that? And that's where it gets into, that maybe isn't a great proof. Okay, so the one that really made the day for Einstein's credibility was the prediction that light would be bent twice as much by gravity. So not only do they have the prediction that it'll be bent by gravity, which was still kind of like, well, who knew? Newton couldn't make a guess because Newton couldn't say whether light was matter and had mass or whether it didn't. So the very idea that if Newton was to state that light would be bent by gravity, then Newton's prediction would just be based on its velocity, right? Because gravity is about velocity. It's not really about mass. Each unit of your mass gets affected the same way. So if you add more mass, it doesn't really matter. It gets affected the same way as all the other units of mass. You're not affected by gravity based on your collected mass. You're affected by gravity based on the individual pieces of mass. So anyway, so it's just about velocity. Velocity dictates gravity because really it's all quantized in a sense. It's quantized based on a quantum of your mass. And that's what's really doing the moving, is the individual little BBs. And the individual BBs are the things being affected by gravity, so you really don't have any differential based on mass. There's no differential because everything that's being affected is exactly the same. So it really doesn't matter how many you have, because it'll be affected exactly the same. All right, so trying to make that point. So you have first the claim, okay, that you can bend this force, this thing moving the speed of light. Now, every other experiment ever conducted kind of demonstrates that you can't bend forces. Like no force radiation can be bent by anything. You can't. Strongest magnets in the universe, doesn't matter what you put on it, you can't bend it. So you can't bend light, and you can't bend, all the magnetism would be an example. And things like gravity, you can't make bend, the force of gravity. You can't make it go somewhere else. Something other than a straight line between pieces of matter. So until it hits matter, it can't go somewhere else. It can only go in a straight line while it's traveling. And until it hits matter, it's stuck going in that straight line, and then you can deflect it somewhere. So it doesn't really bend anyway. It gets deflected by matter. So bending is just an it's unintuitive, and it's based on the evidence. There's just not any real strong indication that forces are bent, and then bent twice as much, right? So the Newton theory would be based on the speed of light, that you'd have a certain amount of bending because it's just about your speed. Assuming light is a quantum of one mass, that kind of thing. That it's made of the same stuff the matter would be made of, the same, whatever the unit of mass is. So it seems kind of strange that something that seems that it doesn't even have mass, just has momentum, but you kind of have to have mass to have momentum, blah blah blah. But anyway, that it would be bent by gravity, and then it's bent twice as much. So first you have the argument, forces just aren't bent by gravity. And then you have the even weirder circumstance you're going to pile on top of that. So I found a force that is bent by gravity, and now I'm going to say, for whatever magical reason for which there's no explanation for why light would be special, it's bent twice as much as all the other material objects. So whether you have a proton or electron or all the other silly particles they believe in, light is the only one that's bent twice as much. All right, and so anyway, so they did this experiment, this Eddington experiment, semi-famous, and so it made Einstein. Okay, New York Times headlines in all the papers in all the countries in the world. Einstein is proven right. Okay, because they did an experiment and said, yes, light is bent. Not only is it bent, okay, which still hadn't been proven yet, but it's bent twice as much. Okay. So even if you don't believe the twice as much part, it was still bent, as much as regular gravity. I mean, that's how far off the experiment could be, is that it not only got it wrong about it being bent, they say it was bent twice as much. So if it's an error, it's a huge, gigantic error. It's not just a little tiny error. Well, anyway, so here you have this experiment, 1919, and never repeated. I mean, never repeated with a better telescope and better conditions. So the only time you can do it on Earth is when there's an eclipse. And eclipses come in all kinds of varieties, where you can have an eclipse on the horizon, or you can have an eclipse at 12 noon. You can have eclipses in all kinds of ways. And so the problem is that some eclipses just aren't really great eclipses because they're not, they're late in the day or early in the morning. You get it, the sun's, you have to go through a lot more atmosphere to see next to the sun. Coincidentally, the United States, the place where there's the most technology per inch on Earth, well, I guess it used to be. Who knows what it is now, where it stands in that category. But lots of telescopes and lots of technology. Right across that, right across some of the best technology we got. Perfect 12 noon eclipse, and nobody repeated the experiment. So even though it's one of the most famous experiments in physics, even though it was within 2 years of the 100th anniversary of the first experiment, even though all of those things nobody did except some amateur guy who used a digital camera and star charts and a crappy little 5-inch telescope. Nothing even close to doing it better. Just doing it on the cheap. So he just did a really cheap version. It's not even that cheap, obviously, but I'm just saying, nothing like what you really should do is try to do it with the best technology. And so he verified it, but I mean, he's an amateur using crap. Okay, so not a really great repeat of the experiment, but that's the best they have. So in 100 years, the best they have is an amateur with a crappier telescope, a crappier camera, but a really good eclipse. So we'll give him that much. He had a really good eclipse, but everything else sucked. But you're just saying why? Why wasn't it done? Then for 50 years, we've had satellites in space, and in space, the resolution is 4 times better. No, 40 times better? No, 400 times. 400 times clearer view. 400 times. And see, you're trying to see something. You're trying to view something. So the resolution is 400 times better I mean, it really does realistically mean that your telescope can be 1/10 as big, and you're still got a 200% improvement. Your telescope can shrink, and you're still way ahead because the clarity is so much clearer. You can see so much better. So it's just a gigantic improvement. That's why there's a Hubble telescope, you see, is because it's a huge, gigantic advantage when you want to look at stuff in, space. A huge advantage to get out of the dirty atmosphere. Gigantic, huge, monstrous, tremendous advantage. All right. And so with all of that technology, where now you could just pretty much use a GoPro. You could just have a really, good GoPro, put it on a satellite, spend 10 minutes taking some pictures, and send them back to Earth and do the experiment. So you don't have to have an eclipse. You can do it anytime you really want to. You can do it as many times as you want to. You can do it over and over and over again, almost for free. No trouble at all, and it's never been done. So in all 50 years of all that technology up there, nobody at NASA, nobody anywhere said, oh, let's just try to do that Eddington thing. It'll only take 10 minutes. So the odds are is they did try it, and they said, gee, this isn't working too well. I guess there must be something wrong, so never mind. let's not bother talking about it, because we probably just did something wrong. Even though we have 400 times better resolution. So it doesn't make any sense. Does it make sense to you? So that makes sense to you. That physics, that says right underneath physics, it says, repeat your frickin' experiments or you're lame. Okay? Your physics is lame if you can't repeat it. You never repeated it. Kind of like the Allen aspect experiment, lots of different experiments they never repeated. Just do it once, and so we can, say it worked, and then just pretend all the times it didn't work. We won't talk about those. But anyway, that's a different accusation, so I won't bother going that far. But isn't this enough evidence? So one of the most famous experiments related to the subject of this whole bent space, Einstein-Wright thing, never repeated with better technology, under better circumstances, under easier circumstances, under 400 times better resolution circumstances. Just not done. And it makes no sense that it wouldn't be. And it's a clear, huge deficit and defect to the evidence. You're relying on 1919 evidence, right, in 2020, and you're still saying that's good enough. We don't have to repeat it. We don't have to do it right. And it doesn't make any sense. It's unscientific. At the minimum, it's insanely unscientific, and at the maximum, it's clearly an evasion of the truth, because they don't like the truth. All right, so that's one strike against Einstein's theory, right? I mean, bent space, blah, 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 fine. As a nothing explanation, fine. But this idea that light's bent, forget about it. That all circumstances are equal, another kind of silly statement to make. So then you have the Einstein thought experiment of the light clock. And clearly the light clock, you send light across the spaceship, and as your spaceship is moving faster and faster, the light will hit a wrong place on the side, because the light's not going any faster, technically, than the spaceship's moving away. So by the time the light gets there, it doesn't hit the target anymore, it hits below it. So it's essentially a speedometer. And that argument kind of undoes the whole theory of Einstein's. The whole point of having light bent twice as much was to make it match that thought experiment. So even there it gets kind of silly. And then you're saying, well, the thought experiment itself is already telling you all things aren't equal, that I can tell. If I had good enough technology, I should technically be able to tell, no matter what speed the side of the ship is going, I'm going to see the bending. See, it isn't some sort of Lorentz contraction crapola. All the bending happens only when you get to the supersonic speeds. With light bending, you'll see the bending no matter what speed you're going. It's going to be there. It's just that it's so minute that you're not going to be able to detect it with the technology we have now. But the speed is clearly it's a straight line progress. It's not like it's some sort of contracted progression. of bending. So it's another reason not to believe this, crapola, because it's somehow dependent on these things being equal, and they're really not equal. Okay, the amount the light is bent on the spaceship is not Lorentz contracted, so it doesn't fit the model. It isn't bent in this funny curve. Okay, so it's not fitting for that reason. So another reason not to believe. And then the people who would suggest that, well, the light never does, because if I actually do the experiment, I actually get into a spaceship, go half the speed of light, I'll actually see the light jump to the future. That is, it'll know it's supposed to go up here, and so it'll headlight, and go to the future. Well, if it did that, then Einstein's wrong again, because then he's supposed to be making the spaceship equal to what's happening on Earth. So if the spaceship flashlight bends the light up to hit the right place on the target, then that's supposed to be happening on Earth. So if that's happening on Earth, why would you have light bend? Because now it's not supposed to bend. Now it's supposed to look like it's normal. So how can you have that both ways? I mean, some of these arguments are, you really have to know something about the history. Sorry. You just have to know something about the stories they tell about how all this crap works to get the subtle points I'm making here. But those are dramatically inconsistent points. You can't make both arguments. You can't say I'm going to make it look like this thought experiment. I'm going to make this thought experiment look like this thought experiment, and then have key features that are fundamentally different. So I'm just pointing out there's huge contradictions in the theory. It's paradoxically broken as a theory. It doesn't work. All right, then the last one on relativity I got to is this idea that the clocks measure time. So time changes, and so clocks measure the change in the time. It's not that you just break the clock. No, it's that the clock is actually measuring time accurately, and time changes when you move at a speed. Now, the sensible argument is no, you just break clocks. So you have lots of ways to break a clock. You put it in a glass of water, you break it. Timex, okay, it can survive the water for a little while, but I can put it under a candle and I can stop it from working. I can do lots of things to screw the clock up. So atomic clocks, it just happens that decay of radioactive particles, see, they say something like, it has a 10,000 year half-life. Well, it really doesn't, because it really just depends on where you have it. You put the little radioactive isotope over here by itself, and okay, it's 10,000 years. But if I put it in a crowd of other little isotopes, well, it cuts down to 4,000 years. I can change the decay rate by just changing the environment the decaying thing is in. So clearly decay isn't about something inside of the decaying element. It isn't deciding when it decays. The environment's deciding when it decays. So now the argument is now I'm going to start moving this radioactive element around. I'm going to move it from here to here, and I'm going to say, it decayed less fast because it was moving, and therefore it's telling time differently. It's measuring time. So it's somehow something happened to it where all of its metabolism slowed down. Everything that happened inside the decaying atom slowed down. See, it's like they're saying the decay rate is inside the atom, when no, it's in the environment. You can trigger the decay by changing the environment it's in. So yes, when you move one, you delay the decay. And there's lots of rational reasons you could come up with why that happens. I've given a simple Star Wars kind of example where, the truth is that you have to hit the inside of the atom has to be hit by two pieces of energy that hit exactly at the same time on the center of the nucleus. And if that doesn't happen, if they don't hit exactly at the same time, you don't get a decay. That is, the isotope doesn't break into two. And so if I start moving something in a direction and it's getting hit by even pressure on both sides, when it's standing still, but as I move it, okay, then I start to bias, and one side gets hit by a whole lot of stuff and the other side gets hit by a whole lot less. So now when you have to have a simultaneous event, you can't really have it. Your odds of having one are radically reduced, because half the ingredients you need are now much less. So even though you have more flour and water, you don't have any sugar, kind of thing. So you can't make a cupcake. Cupcakes have become a theme. Yeah, so that's what this channel is. That's who I am. I am the man who uses cupcakes as a reference. I'll point to them as an example now and then. Take the example of the cupcake. I'll do that now and then. So that's who I am. Alright, so anyway, so those are the arguments, right? So this whole idea that, yes, there's a connection between velocity and breaking atomic clocks. That's what's been proven. That's what's been demonstrated. That's what the experiments show. They don't show any of this other stuff. So, like the light example, right? So I can give you these other examples. See, they don't take a Timex watch and make it time dilate. They don't even take a rat's metabolism and make that dilate. You know, they don't have a forever rat, you know, because they move it around in a circle a lot or do something else to the rat to make it live forever. You know, and we don't get any examples of this, you know, this time traveler, this go to sleep, and, you know, it's really just cryogenics, right? You're just really talking about a way of ceasing certain functions and saying you go into cryogenics. Well, there's no evidence that the complex metabolism of a human being is in any way affected the same way as an atomic clock. You know, we're not radioactive isotopes. It's not that simple. We have lots of moving parts, and they're still going to be moving. They're not going to stop moving just because you're moving the whole human being. Because I'm moving the whole human being, all of the atomic structures, all of the metabolism, all the blood flow, all of the everything starts just slowing down. The heart starts beating slower, and there's no zero evidence that any of that crap is true. So in the case of the light bending thing, they do have experiments where they get bending, but it's all the other experiments where they're not doing the Eddington style experiment where they're actually looking at an optical object. Instead they use radio waves or some other thing where they're not really seeing an image. Okay, and so they say, we got back some piece of a signal. Well, they got back a piece of a signal because obviously in the corona of the sun, the atmosphere of the sun, there's a whole bunch of little particles and lots of deflections. And scatter sends an image everywhere. So it not only sends images to longer paths, you know, where the light goes a longer path, it also sends the ones that give it a shorter path. So yes, everybody gets to view. It's like viewing something in the fog, right? So if you have a little light bulb in the fog, everybody gets to see the light bulb. Right, because the fog makes the light come from everywhere, all kinds of angles, all kinds of places, and so no matter where the light is really going, it doesn't matter because everybody's going to see it, because the fog is going to spread all over the place. All right, so you know, scatter experiments are not gravitational experiments is the real point. So any experiment that could be explained as scatter has to be understood that that's not very good evidence. If the other theory is just as valid, okay, the scatter theory, so you have evidence, you saw something. If the truth is that it could have been explained by scatter, well, since that's the simpler and more reliable factual real event in the universe, that has to be your first definition of what the cause is. So that brings us to the whole mystery of quantum mechanics, which is based on this idea that light changes, you know, that light is bending. It's again another bending argument, except this time it's bending in waves, and the waves are interfering with each other. They're flying through space, these rays of light, and they bang into each other and cancel out and double up and do all this weird crap in space. So even though we have a ton of evidence that can't do that, you know, a ton of evidence, I mean, we shine light bulbs and laser beams at each other, we can't make them bounce off each other, can't make them change, can't make them do any of these, you know, these cancellation crap, none of this crap happens. But we have these other experiments. But the catch of these other experiments is you take two sources, two radio sources or radar sources, and you shoot the rays out, and it looks like, because you get this bar pattern, so you get this on-off pattern, meaning, you know, destructive interference, constructive interference, blah, 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 blah. But the fact is there's an existing theory to explain that. And the existing theory is jamming. We already know you can jam a radio signal. You know, you can send two signals at the same time at a different frequency, out of phase. Same frequency, but just send them out of phase. So they're competing with each other. And if they're equally strong, The radio can't see that this is really this. Can't tell these are going this way and this is, they can't tell it's two signals. They have no clue. So they can't do anything with this. This doesn't mean anything. And so you're just jamming. And so here you have a simple existing solution that tells you when it's just two sources, jamming would be the first choice. It would be kind of silly to say, oh no, they're really banging into each other and mysteriously doing wooey stuff. No. You don't go there, but you already have a really good explanation. It's a really complete, good, mathematically correct, same mathematics, same geometry, same everything. It explains it. You don't go anywhere else. You don't sit there and say, oh no, it's really not the obvious thing. It's this much more mysterious, silly thing going on. This thing that completely contradicts every other experiment in existence. Okay, so yeah, you don't jump to that silly conclusion. But that's not where they went first, you see. So that wasn't the first experiment they did. So because it wasn't the first experiment they did, they jumped on a bandwagon and now they can't get off of it. So the first experiment they did was this silly observation of light. So even though Newton had already done this stuff 150 years before, so this guy Young, an audio engineer, does a crude version of this double slit where you have, two slits and you send light through, the two openings, and you get this bar pattern. This pattern as if the light banged into each other and interfered and created constructive and destructive. Now, I've done a full analysis. There's a video in the subject videos called The Simple, what is a photon? The simple answer or whatever. And so go watch that. It just dissects the experiment, explains that it's not what they say it is. But anyway, the simple answer is to say, well, this is very unusual because we can't do it with two independent sources. So what are the slits doing that's so magical? So in the first critique would be, it's just so silly. So even 200 years ago, this is 200-year-old science now. So they have a 200-year-old theory, okay, that there's two openings and the waves, two waves come out of the two openings, right? So the single photon goes through both the slits and it creates two waves. Well, the fact is that math doesn't even work. If you put the centers, if you put the place where you do your math, if you identify the center of the waves at the openings, right? So you have the opening here and you put the center here of the wave, that math doesn't work. If you put the centers where the impediment is, that doesn't work either. You put it over here, it doesn't work either, unless you have the slit so tiny, because it won't make a difference then. Then the math gets confused. When there's no difference between one number and the other number, when it's less than a wavelength, the math can't say that means anything, obviously, because it's less than a wavelength. It can't be significant in the mathematical equation because there's not a whole number of wavelength differences. So if you make the impediment small enough or the slit small enough, yes, the two-wave math will work, but it's only in those two very rare experiments, the ones you have to contrive. In every other experiment, it's wrong, completely wrong. You get the wrong answer. You'll make wrong predictions. So they say this is the most predictive, most accurate, most super cool mathematics ever in the history of mankind, and here it is overtly wrong, just overtly. So for 200 years, this stupid drawing of two waves has been wrong, absolutely and completely wrong, and they've been selling it, and they're still selling it right now. Right now, physics teachers are sitting there saying, the Young double slit experiment. No, Young's drawings are garbage. The math doesn't work. It doesn't work. It's wrong. It's plainly wrong. Now understand, this is their foundational experiment. All of quantum mechanics grew from this experiment. Richard Feynman will say it. This is the experiment of quantum mechanics. Lots of them have been quoted saying this. This is the whole reason why there is quantum mechanics, is this stupid frickin' experiment. If it wasn't for this stupid experiment, there wouldn't be quantum mechanics. And yet it's this broken. It's this completely idiotic. And so the truth you find out when they do some real inspection. So the real physicists in the background, not the show physicists, not the talking heads, not the propagandists, but the real physicists who are saying, I know physics. I have some respect for the truth. They know that in the two-slit experiment, it's really, the single slit is really the two-surface experiment. The math that works says, I'll measure from this surface and this surface. That's where I'll do my vectors from. So there's two waves in the single slit experiment. There's two sources, and the sources are the surfaces. Okay, the sources aren't two magical surfaces, a little wave in here and a little wave. No. The surfaces. And then they know in the double slit, it's the surfaces, the four sources. So this surface is a source, this surface is a source, this surface is a source, this surface is a source. It's the four source experiment. And those sources will perfectly predict your mathematics. If you just take this distance of these two furthest away surfaces and this distance between the two closest surfaces, and you put that into the math, it'll tell you exactly what pattern you're going to get. It'll predict the envelope pattern. It'll predict how big the central maximas are. It predicts everything perfectly. So if you do it based on the fact that surfaces are causing all of this, then you get the right answers mathematically. Now that's sort of a truth. Some physicists are sort of accepting, well, yeah, that's the truth, but it's still wave interference. Because they're going to contrive some silly notion that these are real waves being created by some Huygens magic on those surfaces. But, to anybody who's logical, they're going to say, this doesn't have anything to do with Feynman. Feynman's saying, no matter where the photon goes in, it goes crookedy. So Feynman's theory is, doesn't matter where the photon goes in, it goes crooked. Okay, it interferes, does this two-wave thing, blah, 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 blah. And the real truth is, right? The real facts are indicating that no, the photons that go through the middle go right through the middle, hit the target. That's why it's so bright in the single slit. That's why the center is so frickin' bright. It's because, the ones that go right through, they don't get bothered. And only the ones that go next to the surface, they're the ones causing all the fringe pattern. So, and what would be on surfaces? Electrons, of course. So the theory, the bold counter theory is that, there's electrons on surfaces, photons hit electrons and scatter. Now that's another thing physics already accepts, okay? They got Compton scattering, they got McGregor scattering, they got, Mr. Hoppen-Poppins scattering. They got lots of scattering, so they know scattering's a real thing. So, it scatters, okay? And that's why it's getting spread across. That's why it's diffracting, spreading. And the reason why it's interfering is because of the same rules. It's phase differences. You can rebuild the photon where you put a piece from here and a piece from here, and you put them back together in phase, you rebuilt the photon. When you put a piece from here and here and they're out of phase, you didn't rebuild, right? That's all it's about. So you have a piece of photon over here and a piece over here, and they zoom together and they match, and now they're in phase and they create a photon. But if it's a wrong distance, then they're out of phase and you got no photon. That's simple, problem solved. All of the physics now matches because now the two source experiments match, okay, the sources created by slits. So when you have two sources, you just create two speakers and you create interference. That you create jamming. Now those experiments all match the slit experiments because now you're just recognizing that you're just creating sources at the surfaces. They're little sources doing the same thing. And so there's gigantic continuity created by accepting the truth instead of the silly theory. And you have no good reason to believe the silly theory now, because now you have a good, sensible, rational theory that the slits are important not because they're creating an opening for waves to be created. The slits are important because they're creating obstructions that are crushing, they're smashing little photons into pieces, and you're sending the pieces to all these locations, and all those locations they're getting rebuilt. That simple explanation far outshines as reasonable the crazy explanation of the electron or photon breaks into two and then creates two wave functions and interferes with the wave functions and then goes everywhere and decides to go only one place though. Even though it went everywhere in theory, it only went to one place. All of that goes away. All the superposition goes away. All the entanglement goes away. None of these crappy, stupid, idiotic notions are now relevant if you just have a rational perception of the reality. Okay. So now let's move on to the third experiment that I found. The third, just evidence that... So I've given you two reasons not to believe, and they're directly related to two subjects that I think are incredibly important: relativity and quantum mechanics. Now there's this third thing where, 200 years ago again, they decided to change something simple. mass times velocity. That's how Newton decided how things would bend. That's, you know, how much things would be affected by another force. It completely works. It's all about how heavy are you and how fast are you going, and that'll tell the world how much energy you have, how much capacity you have to blow stuff up, heat stuff, do things to make action happen. It's all about just how many bits do you have and how fast are the bits moving, and that'll tell you how much of this energy stuff you must contain to be able to do that. You can't move unless you've been impacted by energy and you've caught the energy virus. So energy virus, you know, energy is like a virus. You have to have it. You know, it has to be in you, and it has to be, you know, running you. And that's sort of how it works. You catch energy. Energy hits you and you keep it. And when you give it back, that's when you lose it, okay? You don't get the, you know, it's a real thing moving through the universe, this thing called energy or force. It's not just some kind of, you know, you were forced once when you were 4 years old and you never have to be forced again. It doesn't work that way. The force you catch at 4 is still pushing you at 40. All right, well, anyway, the ones you capture, the energy you capture, you hold, you keep, would be the right rational way to think of it. Well, anyway, so they had a perfectly useful, perfectly works, okay? I mean, you could land on the moon with mv, okay? Mass times velocity. You can land on the moon accurately, do all of it accurately. And so 200 years ago, well, long before we land on the moon with a reliable MV, some idiot decided there has to be something better than that. You know, this living force, this thing called, you know, they turned it into kinetic and potential energy, but they're supposed to add up to the same thing as momentum, and they don't. So they came up with this stupid new formula because a few experiments made it seem like something was more energetic. So I could take a water buffalo, right, and I could put him next to me, and he's just moving a little bit, you know, he's twitching a little. Okay, now the fact is, okay, and then I could take the energy in the buffalo, the energy that's making the buffalo move, and I could put it inside a little tiny 22 caliber bullet. Now, because I put the energy in the 22 caliber bullet, it's going to move really, really fast, where the big buffalo wasn't moving too fast, but it had a lot of mass. Yeah, and the bullet will shoot through my head and blow my brains onto the wall, or something like that. Break the bullet into little tiny pieces, lots of fragments flying, lots of stuff will happen. But the truth is, the amount of energy is still the same. You only have a twitching water buffalo worth of energy in the bullet. You just have it in a small package, a smaller package, moving at a higher speed. And that's the only difference. And that affects matter differently. So it affects matter differently if, you know, if I punch my fist, or I jam my finger, or I take a piece of real thin metal and poke it. Well, you know, a needle, right? It doesn't take much energy to push a needle into your skin. Well, so what? That doesn't mean the needle has more energy. It means that it's taking advantage of the fact that there's holes in my skin, and little tiny ones, and the needle can squeeze through the holes and get through easier, and it's, you know, pounds per square inch and all those kind of arguments. So it has nothing to do with having more energy. It just has to do with the fact that, yes, my physical body is vulnerable to things moving fast, okay, versus things moving slow. My body can react to things coming at me slowly. It can't react to things coming at me too fast. My matter isn't flexible to speed. And the same thing, a balloon is like it, right? You can poke the balloon in with your finger, no problem. But if you jab it fast enough, you pop the balloon. You know, those kind of arguments, you know. So you can understand this has nothing to do with real energy. Yet, because people were fooled by that, you know, 200 years ago, because 200 years ago they were fooled by a couple of experiments that made it seem like something had more energy. So they dropped lead balls from different heights, you know, substantially different heights, let's just point out, you know, 4 times the difference in the height, and one of them goes into the clay, you know, 4 times as much. Well, you had 4 times higher, but anyway, you know, they drew these conclusions because clay reacts to velocity. That is, the faster you move into the clay, the deeper you go into the clay. Because of this one circumstance, they decided to change all, you know, a standard of what momentum is or what energy is to duplicate or to fit that one aberrant experiment. So even though they had a ton of other experiments where you could bang trains into each other, bang carts into each other, bang different things into each other of different masses and different velocities, and it always came out the same. That is, the energy just moved from one object to the other object based on mv. Okay, if you have half the mass, then you have twice the velocity. If you're doing an energy exchange, and if you have twice as much mass, then you have half. It always come out the same. It's always momentum. Momentum gives you the right answer, mv. Well, anyway, they changed it, and they changed it to mv squared. So 200 years ago, the new formula was mv squared. Energy equals mv squared, right? Which is really wrong. I mean, way out of proportion. No reason to believe there's more energy. The speeding bullet doesn't have more energy than the drunk, water buffalo. Not true at all. Okay. Just an illusion of perception. You're just being fooled, okay, by silly notions that that you could recharge a battery. That bullets fired through people's heads would recharge batteries faster than wobbling buffalo. No, it wouldn't do that. You can't heat your house faster with bullets going through people's heads. You can't do any of this stuff faster. 4 times faster, by the way. Can't happen. Well, it's actually 2, but because of the square thing. Well, anyway, so there they had the wrong answer, and they kept it for 100 years with the wrong answer. Okay, mv squared, which is bad enough, right? And then they figured out, okay, that is really outrageously not correct. So let's just stick a half in it. So somewhere around the period of Young's double slit experiment, right, when they're doing all this other shenanigans, they decide, let's put a half in front of it so it doesn't look quite as stupid and silly. So, but that's about the only reason. I can't figure out who decided needed a half in front of it. There's no perfect history that explains to you when they figured out to put a half in front of it. But they did, okay, to make it less stupid. It's still really stupid. It still doesn't make any sense. It still doesn't fit in physics anywhere. It still doesn't fit with 99% of all experimental data. It's still completely wrong, but it's less wrong because they put a half in front of it. So they're trying to save it a little bit. but it's still way off. So anyway, so you got this formula that just doesn't make any sense. 1/2 the mass, so somehow the mass is half as important, and somehow the velocity is everything. So the faster you can make something go, the more energy, and it just isn't true. Okay, if the masses stay the same, yes, it makes it more energy, but it's only as much energy as the multiple. It's not twice as much. It's not squared for sure. It's not even 2 velocity. Like if they had half mass and 2 times the velocity, that would be bad, but it wouldn't be this bad. There's just no. Both things contribute. Matter and velocity are completely the same thing essentially when you're talking about momentum, when you're talking about energy. Both of them play their role. You have to have the mass. The mass is what's holding the energy. The mass is what's holding the velocity. The mass is covered in it, and so without the mass, you can't have any of the paint. The mass is the surface the velocity paint is painted on, or some sort of analogy like that. You can't have one without the surface area the other provides. So there's nothing that they're both required to exist in the equation in equal proportions. They have equal significance. Double the mass, double the energy. Double the velocity, double the energy. They're equal contributors. And that's what every single good experiment proves. And yet, all of physics uses this stupid formula. So when they're telling you what the mass, when they're telling you what the energy of an electron is, they're telling you based on this idiotic formula. So they'll say the electron has 970,000 joules of energy or something. And they're doing it based on this completely wrong formula that completely distorts the importance of velocity and completely misses the importance of mass. So how can you trust physics? This profoundly broken. Again, there's just no doubt about it. It just can't work. They can never do an experiment where they'll show you them collecting this energy. So this fake kinetic energy they say exists that's completely more than the momentum. So anytime they do the math, mv, and then they do 1/2 mv squared, and they get these 2 completely different numbers. There's no excuse for the two completely different numbers. This one, MV, is always the right answer, and this one's always a wrong answer. And they can't do any, when they go to try to get this extra energy, when they try to extract it, there's no way to extract it because it doesn't exist. The only energy they can ever extract is the MV energy. They'll never extract the 1/2 MV squared energy from any experiment ever, because it would essentially be free energy. All you have to do is bang light things into heavy things, and you can make energy all day long. No, bang heavy things into light things, and you're making free energy. But banging heavy things into light things, oh shit, are you out of luck? You're losing energy all over the place. Something like that. Or vice versa. Doesn't matter. The point is it creates free energy, and it's just not real. It can't happen. It doesn't happen. There's no experiments demonstrating it happens. So here they have something so insanely stupid, and they have it as a real structure in their mathematics. It has a terrible history. There's no history that's really great for this equation. It was called the living force. Okay, people like Voltaire said it's crap. Okay, so at least you had some warning that it's crap. And it was completely invented by a bunch of, fiddle-faddle elitist, talking heads, and they just invented it. Okay, there wasn't any good science behind it. There was just a Ken Wheeler with his Faro cell. I mean, it's really literally that bad. It's like Ken Wheeler showed up 200 years ago with his Faro cell and said, see, light's bent by magnetism and blah, 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 the ether, counter space, under space, blah, 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 and everybody fell for it for some reason. There wasn't anybody at the time strong enough to stop it, like Voltaire. Somebody better than him. Yeah, so I guess you needed. But anyway. So it lives on, and it's complete garbage. You can't make any sense out of it. I don't see how anyone can make a logical argument defending it. It doesn't make any sense that this is a fundamental formula in physics, used all the time, as if it's accurate, as if it's getting right answers, when it can't get the right answer. It's impossible for it to be getting a right answer. It's nonsense. You can't... you can't have it both ways. You can't say energy is conserved and then say, well, I bang a heavy train into a light train, I gain joules of energy. And when I bang a light train into a heavy train, I lose joules of energy. It's nonsense. All right. So those are the biggies, the big pieces of my objection to conventional physics. They're all based on these cornerstones, like New York Times headline, Einstein right, made Einstein a household name, made Einstein too big to fail kind of thing, too big to knock down, too big to argue with, and so we're stuck with this silly relativity, wooey time, dimensional bibble babble that has no, time is just a function. I didn't even go into the fact that time is just a function, because the fastest thing in the universe moves kind of slowly. That's why there's time. Okay, if the fastest thing in the universe didn't move slow, getting from one point A to point B, there wouldn't be anything. We wouldn't even be having this conversation, because everything would have happened instantaneously and would already be over. Okay, so it's just that, yes, the universe has slow parts in it, and so there's time. As soon as you have something moving slower than instantaneously, you have time. That's it. That's the only definition. It's a function. It's not a dimension. It doesn't, dimensions are supposed to have right angles to each other. Where's time's right angle to any of the other dimensions? Oh, that's right. It doesn't right angle to any of them. So why are you calling it a dimension when it doesn't even have what a dimension's supposed to be? It doesn't fit in the category dimension. You shouldn't even be using these words. I mean, you're cheating, reason so much by saying I can have things. I'm going to call something that doesn't fit in the category. I'm going to say that some fish should be called dogs. Well, you don't see how that just breaks any kind of conversation, because I'm going to say dog, and I'm going to mean the fish dog, not the dog. I mean, you can't have a conversation. Spin doesn't mean spin. Wave doesn't mean wave. Function doesn't mean function. I mean, they've broken all the vocabulary, so that's another reason to have such doubt. And here and all you get from these people is insults. Where did you study physics? Who cares where I studied? Where did Faraday study? He studied in a frickin' basement, just like I'm doing. Okay, that's where he studied. It's just you're just such assholes. Where'd Benjamin Franklin study? I mean, yeah, you're just such idiots. What's your degree? Well, where's their degrees? Where's the best humans in the history of humanity? Where are their degrees? Their degrees didn't make them. Their freaking capacity to pick at the institutions is what made them great. And you're just all such defenders of a status quo. You're just so team oriented. Your team wins whether you have the players or not. You just don't care about playing a nice good game and showing that you can hit more home runs, showing that you can do all this crap. You just say you did it. You just make up a story. Oh, we beat you 25-0. We totally shut you out. You're just telling a story, okay? You're not doing any of that crap. Ugh, fuckers. Anyway, all right. So enough of a video. Yeah, it was a lot of a video, I think. More than I intended, but maybe I'll just, maybe I'll make fewer videos, and maybe I'll start doing some writing, which I really hate doing, because I really don't think it really shouldn't be relevant, in 2021. No. Everything should be on the illustrated. Everything should be full armored technology. We should all be coming to the conversational table with all the argument tools. Not the ones we had 500 years ago, even, or 1,000 years ago, 10,000. I don't know when the first book was written. I don't know. The first crap written on a piece of paper. But we can do so much better than that. I mean, we don't have to really have rolled up parchment. We can do better than that in terms of making points and arguing and discussing and all that kind of crap. I mean, it's really just about arguing, for fuck's sake. Come on, get real. Conversations really aren't worth anything. Discussions really aren't worth anything. All right? Point, counterpoint. That's worth everything. Anyway. So, till the next time, and such, so forth and whatnot. Yeah, I don't know. I am ghosting quite badly, but whatever. I'll work on it. So, this has been a DraftScience video presentation. Till the next time, and such.